about ZK products, where we break them down with rich flavors and sweet insights. I'm Omer, and I'll be co-hosting this episode together with Queenie. Today, we're thrilled to be joined by Deepak Maram, applied cryptographer at SUI. I hope this one is going to be cryptography heavy, and I cannot wait to start. So Deepak, it's great to have you here.
Hi everyone, this is Deepak. I'm a senior research scientist at Mysten Labs. Prior to that, I was doing my PhD at Cornell, and straight out of that, I joined Mysten Labs, and I've been working here ever since. Very excited to talk about all the cool things we're building today here.
Awesome. So let's start easy. What is SUI?
SUI is a so I want you guys to think about SUI in the context of, let's say, Ethereum. We have Ethereum, which is sort of a general purpose blockchain which supports general purpose smart contracts. That was, I don't know, 10 or 15 years ago, old at this point. Now SUI is very much in that league of blockchain, so it aims to be general purpose. It aims to support general purpose contracts. Now the key innovations of SUI on top of something like Ethereum are multifold. We have much faster consensus. We have a much more secure programming language called Move, and we have a lot more. And these two features together mean that we can support richer things on chain. For example, ZKLogin is one of the things we'll talk about today. At a high level, the high throughput and high security is sort of is what sets SUI apart from other chains, especially like something like Ethereum.
So your colleague Kostas recently asked on X the following. If you hired our cryptography team for 1 year, probably the strongest applied crypto research group in the world, what would you build? And I want to ask you, how is it like to work in such a team?
Yeah, maybe to give a little bit of context about the team itself. So this team, much of the team is coming from Meta, which sort of had a incredibly strong research team, and much of the research team that is at SUI now comes from there. So we have incredibly strong researchers across different domains, consensus, cryptography, networks, and even some people in PL and economics. In fact, if you look at it, I think we have published something like 80 plus research papers and reports. Just these are the number of works published by the team while being affiliated with Mysten. So this is not even including like earlier works of all these researchers. So this is like an incredibly high research density team that we have at Mysten. So it's quite exciting to be part of this team. My only wish is that we meet physically more, so we can ideate even more than we already do, because this is such a strong team, and it's always a pleasure to kind of work and meet these people and ideate together. You can also see this in, I think, the amount of products we've launched. Just over the last few years. SUI, of course, came about 2 years now, I think, 2 years ago now, I think. But ever since this, we've launched Walrus very recently, which is our decentralized storage protocol. We've launched Seal recently, which kind of builds on top of Walrus to enable like file storage or secret storage. It's more of a secret management system. And I'm sure we're going to dig more into all of this later, but so I think at a high level, we both publish quite rapidly, and we also kind of launch a lot of products compared to I imagine any other team in the space. So it's quite exciting to be part of such a team.
Would it be okay to share how big is the research team and how many of them are focusing on cryptography?
Yeah, sure. So we have let's say about 5 researchers on the systems side who focus on, let's say, consensus and general systems aspects, and we have again 4 to 5 people on the crypto side. And obviously there is some overlap between the two teams, and sometimes between the type of projects we're working on where we need both types of people. And we also have, let's say, 2 or 3 people working on computer networks. We have and then a few people in economics and PL as well. So like if you club it all, I think it'll probably come to somewhere about 10 to 15, I suspect. That is sort of the total size of the research team, and obviously cryptography and systems are the two heaviest aspects where like most of the focus goes.
That's very cool. So I'm curious, was ZK always part of SUI's DNA, or did it become a focus as the platform evolved?
Yeah, so I think in terms of the expertise we have on the crypto side, again, I think it's a very diverse expertise. People have expertise in zero knowledge, MPC, anonymous credentials, and all of these aspects, like both on the theory and applied sides. So I think we always kind of have had this background where people kind of knew, had sort of expertise in all this stuff. In terms of the focus of the company itself on the ZK side, I think that happened very organically. I think when I joined Mysten, for example, we were just brainstorming what is a better way of authenticating users, and that is how ZKLogin came about. It wasn't that we were looking at ZK as a focus area and trying to figure out what to do in there, because like ZK for ZKLogin came about very organically, because that was basically the only way to do it.
So we established that there is a research group within the org. What are the interfaces of this like research group with other teams? How does it look like?
Yeah, that's an excellent question. I think the interfaces are quite interesting, to be honest. Especially on the crypto side, I think the interfaces are very clean. So we have a cryptography team that does both research and engineering. So it's a small self-contained team which has both researchers in it and engineers in it, and some hackers in it. So it's so on the cryptography side, I think it's somewhat cleanly defined, because okay, at the end of the day, I suppose I think that kind of works for cryptography. But on the system side, I think it's a little different, the interfaces, because obviously the heart of SUI is consensus. So we have like a much bigger team that kind of maintains SUI. So there's a much bigger engineering team, and there's a much smaller research team that tries to interface with that much bigger engineering team in various ways. So I think that at a high level, that's how the interfaces look on both the systems and crypto sides.
So I want to talk about one of the recent products coming, I guess, from this group called ZKLogin. You recently also gave a talk about it at Real World Crypto. Can you explain what it is?
Yeah, sure. I think I can pick up where I left off from my conversation with Queenie last. So this was essentially this essentially began as a quest to make user onboarding easier. As we all know, traditionally blockchains always just required people to remember a long mnemonic, and that was the only way for users to directly sign transactions on a chain. This is obviously extremely bad for various reasons from a user experience perspective. Like people are already kind of struggling to remember passwords, and you show them like a gigantic password and ask them to remember it, and this is like their first experience interacting with the blockchain. So obviously this was like I think this is sort of clear to probably everyone in the space that this is like, okay, not we kind of need to do better than this. And this was the starting point for us. We were researching or just brainstorming what can we do better here. And like for us, a natural starting point was just thinking about how password management has evolved in the internet, right? So people don't necessarily go around creating new passwords for every website they go to. They often reuse an existing account to log in, and that is how they ease the burden of going around the web without having to remember a new password. So we were just kind of thinking from along those lines, and trying to figure how to make that work for a blockchain setting. Um, so that is how ZKLogin came about. We realized that there is this detail in OpenID Connect that would allow us to do this in a way where we don't need to introduce another custodian into the picture. And that was sort of the aha moment for all of us, and from there on, there was no looking back.
So, Deepak, I think ZKLogin does improve user onboarding and enhances privacy to some extent, but does it actually introduce any new security risks?
Yeah. No, I think that's a great question. So I think first things first, we were always introducing ZKLogin as a solution where people were comfortable with using with trusting the security of a particular OpenID provider. Maybe that's Google, maybe that's Apple, or whoever it is you choose. So we were always intending this as sort of a bootstrapping wallet for users. So this is, I imagine a user who has never heard of blockchains, they come to the space, and like, okay, this, what do we show them to onboard? Like this is what we show them to onboard. Now, coming to your question of like, okay, what about the security risks associated? So obviously, in the simplest instantiation of this, it means that if your Google account gets hacked, for example, then therefore your blockchain wallet might also get hacked. So that risk is always that risk is there with ZKLogin. But there's a bunch of ways of mitigating this, and the way we are thinking about this is that uh, so I'll give you a few examples, right? So first of all, we've enabled something called multisig with ZKLogin on SUI. So as a user, you could use a multisig that has ZKLogin as just one of the factors. So maybe you use Google and Apple, or you use Google and mnemonic. And it gets really interesting here, just to think about some ideas around the space. Yeah. So for example, here is one idea where you could combine ZKLogin and mnemonic and add a delay. So for example, you let's say that all withdrawals take 1 hour. Now you use ZKLogin to initiate the withdrawal, but in that 1 hour you can kind of cancel it with your mnemonic, which maybe you store deep down in your house that you rarely need to use, right? So in all the common cases, you would just use ZKLogin with just a small delay. But in the worst case, if your Google account gets hacked, you have an hour to go and fetch your mnemonic to to kind of make sure your account is safe, right? So I think there's a lot of interesting, innovative ways to be found, to be explored, to kind of combine ZKLogin with mnemonics and other things to make this both secure and user friendly, so that people don't need to make this trade off even in a long term sense. Like, okay, if you want to let's say you're a user who has used blockchains for a year, and now you're like, okay, I don't want ZKLogin anymore because I'm managing high value of assets and whatnot. So I think there's potential there to still think about ZKLogin as one of the factors to make it, as I said, both secure and usable. Which by the way, this idea that I mentioned is a plug to one of my recent research works, where we kind of talk about this type of delayed withdrawals and sort of the security it gives. So I am hopeful that there's scope for ZKLogin, even for wallets or users who are considering this for like long-term use or like high-value use.
Cool. Is the multi-sig approach similar to social recovery?
I think it has parallels. Yes, indeed. So you could one way to do this would be to loop in your friends as you are as your recovery factors. But yeah, so it could also just be a credential you don't give to your friend, but you store it in your basement, right? So it's I think it's in the same bucket of ideas. Um, the I think the let's say the cool thing in the scheme that I mentioned was this idea of a delayed withdrawal, which gives you time to react if something bad happens. So it's sort of combining delayed withdrawals with social recovery, let's say.
I see. And it also reminds me of the MPC approach. So how can we compare MPC approach with ZKLogin, the pros and cons?
Yeah, okay. MPC approaches can mean lots of things. I think if you're referring to something like, I believe there are some MPC wallets out there like
Yes,
Zengo or even
yes,
Coinbase
Web3
does
auth.
some MPC. That's right.
Yeah.
That's right. So Web3 auth is maybe Web3 auth just does. Do they do a MPC? Okay, I'm not entirely sure. Anyway, uh, okay, so how does this idea of social recovery compare to MPC? Yeah, that's your question.
I mean, a ZKLogin
In
solution.
general, I see.
Yeah, in general.
Okay, so ZKLogin doesn't have any MPC in there, right? It's quite simple in that you are using your Google account to log in into a blockchain, and if your Google account gets hacked, there are some risks to be wary of. With MPC solutions, I'm not entirely sure that they're trying to solve the usability side of it. Um, I think generally my impression is that generally they're sort of okay with a semi-custodial model where, let's say, majority of the nodes kind of have your secret shares and can in theory act as a custodian for you. So in ZKLogin, we're not introducing any new trusted entity, right? It's just you and your OpenID provider. Um, that that that's it. So there's no other party that we're adding to make the system work, which is I think like a key differentiator from other MPC systems where you're introducing MPC nodes who hold shares of your secrets.
Mm-hmm. Yeah. I feel like a ZKLogin sounds like more self-custodial, only self. Yeah.
Exactly.
So,
Yeah, I think it's just it's basically we're reusing existing trust models, right? If you already trust a particular website for whatever things, then that's it, right? Yeah.
mhm. Yeah, and I think Swiss ZK login is likely one of the most widely adopted ZK features to date.
Oh yes, that's
Yeah,
right.
with like over 1.6 million ZK proofs powering more than 4 million transactions. That's amazing. So I'm curious, have you encountered any challenges or bottlenecks in scaling ZK to this level of real-world usage?
Yes, most definitely yes. Yeah. So as you said, I don't think there is any other application that kind of generates this many zero knowledge proofs on a day-to-day basis. Um, but at least it's probably one of the top ones that is doing so. And in terms of the scaling challenges, yeah, I think um, we've faced this a couple of times in the last year or so, where it's like we suddenly get a burst of traffic, and whatever sort of load management system we have is kind of insufficient to handle that level of load. So, for example, let's say you get X requests per second in sort of a traditional in the normal setting, but suddenly you get 100x, and you need to have the capacity to generate 100x zero knowledge proofs, which I don't think we have the solutions or the capacity yet to kind of deal with that level of load. So the way I say it is, we obviously optimize along the way, in the sense we try to make proving times lower. We try to make client-side proving a reality, and as soon as this starts to happen, we can start offloading the load and sort of solve the scaling challenge by moving the proof generation onto the users. This is sort of my short to medium term take on how we are going to handle something like this. Maybe we get a breakthrough and we get like a proving system that is both very fast to prove and has short proofs. And then, okay, that is another way of solving this, because I think ZKLogin, one of the challenges with ZKLogin compared to most other ZK applications is that it's extremely latency sensitive. Like, users are not going to wait a long time, and it's also extremely proof size sensitive. Like, you don't want to post long proofs in your signatures. So this combination makes it, I think, deadly. And hopefully, if any researcher is listening to this and wants to come up with something better than Growth 16, or something where we can really get both fast provers and like short proofs. So I think this pushes the edge of ZK in certain ways that I don't think other ZK applications do.
Are you outsourcing the proofs at the moment? Like, how do you make it secure? Or it doesn't really matter who generates the proof?
Yeah, that's a great question. So we have a secure way of outsourcing the prover, secure in the security sense. So there is a privacy leak here, which we can talk about, but the outsourcing is secure from a security standpoint. The basic idea is fairly simple. I guess we're probably going to get into the details of ZKLogin now. So the key idea is to embed a key pair within the OpenID Connect flow. So I think to give a high level perspective, I want you to think of it as a user generates a fresh key pair every time they open their mobile app or extension, wherever their wallet is. And there is a way for us to make Google act as, or any other OpenID provider act as a certificate authority, signing over the public key that you just generated. And that is those are sort of the details of the OpenID flow that we can get into if you're interested. But once that flow ends, the user has the key pair and a certificate from the OpenID provider that certifies that this public key belongs to you. And this is sort of the key idea that allows us to outsource the proving, because what we do is the key pair, essentially, meaning the private key, never leaves the user device, and we only outsource the zero knowledge proof part, which is sort of the rest of it, to a third party proving service, and this service is essentially proving that there is this certificate issued by Google which has this public key in it, and it belongs to you, the user. So that at a high level, that's the zero knowledge proof it generates. So that's where there is a privacy leak, because it is seeing the certificate, and there is no security leak because there's no security issue here, because it never sees your private key, the fresh key pair that you generated. And therefore it can't sign transactions on your behalf. Does that make sense?
Yeah, it's actually very smart. I want to bring it back to the topic we discussed earlier about like the cryptography team and the research team. So I assume ZKLogin is like the technology came from like that group. How do you implement it in the context of the protocol? I see in one of our notes that we kind of like understand it as more of like a wallet type of like technology, yet it is embedded as part of the protocol. Maybe we got it wrong, but can you explain how do you take this technology after the aha moment and the security and formalities, and then the implementation, and like put it inside of like the bigger like the product?
Yeah, sure. Yeah, so I think, yeah, it obviously started with the aha moment, and then we were just trying to benchmark and see how it works, how fast it works. So once we were satisfied with the performance of it, then I think so obviously since we were using Groth 16, there was the whole trusted setup part that we had to manage, which was, as you might imagine, one of the big sort of organizational challenges we had to face in launching this out. Um, in fact, with regards to trusted setup, like I can share a few anecdotes. Like we always wanted to have like a dual path for the trusted setup. We didn't want people to have, I don't know, terminals and Docker images to be able to contribute to the trusted setup. So we wanted this to work in a browser setting as well, where people can just go to a website, contribute, maybe have to wait for 10 minutes or so for their turn to come. So yeah, so this took a lot of effort, engineering effort from our team to build out this platform, but of course also organizationally. Even while we were running the trusted setup, it was a challenge in the sense that people had to kind of contribute sequentially to this. So we had to tell people when to come, make sure they're not waiting like hours on the website. So this was quite an organizational challenge for us. In terms of, let's say, the other aspects of integrating it into SUI itself, so there's sort of two things I think we're talking about. One is the Oracle aspect. So we need someone to be posting Google's public keys on chain periodically. And the way it works is that these keys are rotated periodically, so it's not the same key that was, let's say, a month ago. Now, we didn't want to introduce any external dependencies into the system, so the way we did this was to basically make our validators act as oracles, fetching these keys periodically. So that was one sort of key change. The other was thinking about at what level into SUI we wanted to introduce this. So at a high level, the way SUI works is we have some native authenticators, and that layer is completely stateless or almost stateless. And then we have the proper, let's say, smart contract execution, where you need the full state to kind of execute transactions and whatnot. Now, we really wanted to put this at the stateless sort of layer. I guess a listener might realize that, okay, ZKLogin isn't 100% stateless. You do need like the public keys coming from the validators. So it is slightly stateful, but it is like basically stateless. And that is... and that was very important because, as you might imagine, verifying a zero-knowledge proof is like 2 or 3 orders of magnitude more expensive than verifying a traditional signature. And we did not want to make using ZKLogin expensive for users. So we don't actually charge more for you using ZKLogin today, for example. So the reason we're able to do that is that this is a completely stateless layer, right? So we get a transaction. You can just verify this transaction in a completely stateless manner. You can throw as many cores or threads at it as you want. And therefore, even though it is a little more expensive computationally speaking, it's fine. So yeah, that's that. At a high level, that's sort of those are sort of the challenges of actually going ahead and integrating this into SUI, running a ceremony, generating a trusted setup. So those were the main challenges.
So Deepak, besides ZKLogin, I noticed that you guys also have other ZK initiatives. For example, the ZK Lite client. So what it's aiming to achieve?
Okay, so why do we need ZK Lite clients? So traditionally, the way Lite clients work on something like Ethereum is that you kind of commit to the whole state using, let's say, a Merkle tree, and whoever wants to access parts of the state can request a full node to give you a proof that at a particular block height, what is the state of a particular thing. So now this is not nice in a couple of reasons. And so firstly, if you have a whole Merkle tree over the entire state, then you're going to have to do a lot of IO in while you're executing transactions to update this tree. This is kind of why Sui doesn't have such a global state tree. Secondly, even if you had a state tree, like people tend to want to index state in different ways. Like you may want to ask a particular question that isn't readily answerable by the exact state tree that a particular chain provides. So these were sort of the two reasons we started looking at ZKLite clients as an option. And at a high level, the hope is that validators only do work that is proportional to the number of transactions they get, and not more. And and we were imagining if it would be interesting to have like a ZK service on the side that could take these commitments that validators are producing and then build like a global state tree on the side. So this was the sort of research idea I mean, this is sort of something we are currently working on. I don't think we've even kind of released anything about it. I'm surprised. Maybe you learned it through a blog post. I don't know how you got to
Yes.
know about this.
Yeah, I
Um,
read your blog post.
I see. So yeah, so this was sort of the base idea where we were trying to offload work from validators onto like a third-party service that kind of does bulk of the job. Yeah, so this is sort of a research paper that hopefully you'll see coming out soon.
Looking forward. Cool. And I think like the initiatives like ZKLogin, ZKLite clients, and identity sort of stuff are being explored across various blockchain ecosystems, like Ethereum you just mentioned as well. So do you think the crypto space will eventually converge on similar ZK approaches?
When you say similar ZK approaches, do you mean like similar proving systems or similar?
Uh, like 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 for example, we find out yes, we should all implement ZKLogin, ZKLite clients.
I see.
Yeah.
Yeah, that's a good question. Um, I think there will definitely be some conversions because like for each of these use cases, there is like a strong motivator, like ZKLogin usability. Anyone who wants like a very usable, user-friendly wallet will, I think, naturally have to think about something like ZKLogin. ZKLite clients, I imagine the driving force there might be more like short proofs. Again, like anyone who kind of wants short proofs will kind of naturally think about ZKLite clients. I imagine there will be divergence in like the exact type of ZK statements people are proving, and like details like that. But I do think there will be like a broad convergence in some areas, like as you said, like ZKLogin. I think with ZKLogin we've already seen many blockchains are opening similar solutions. With ZKLite clients, I think again I think people will start using them when certain things happen, like proof sizes become too much, or like in the case I mentioned where it's like it's too much load on validators and therefore they want to offload it. So yeah, I certainly think there will be some convergence here, at least at a high level.
So Deepak, I've noticed that one of your recent published works is an SOK concerning range proofs. How does it have to do with anything? Like, what's the context here? What's the motivation?
Yeah, my feeling is maybe this is not like such a deep question. Let's see if you guys feel like it's interesting, but I'll share what it is. So this sort of came up in the context of confidential transactions, which was something we were looking at. I think this happened last summer, if I remember correctly. Yeah, so in that context, we were looking at what are the options for range proofs. So we were thinking about not full-fledged like Zcash style chain, but like just hiding the amounts was sort of the level of confidential sort of privacy we were looking at, and so that is sort of the context it came up. That I think that effort did not really go anywhere. We kind of prioritized elsewhere temporarily. I think it may come up. We will see if that happens. But so that's the that's the backstory.
I think no shame in you do research. Your job, I guess, or part of the job is to look into ideas, start threads that not always you bring into a certain completion. Like sometimes you need to park it, continue at a later point. So that's very reasonable. So another project which looks to be something big is something called Walrus, which was announced not long ago. And according to the announcement, it is positioned as a next-gen, fully programmable, decentralized storage with enhanced security, privacy, redundancy, and replication efficiency. So that's a mouthful. Can you maybe break it down to us in simple words? First, what does it mean? Why now? Yeah.
Yeah, sure. So I think the goal here is to store big files on decentralized platforms. Now, if you want to store even a big NFT on a public blockchain, it tends to cost a lot. And this was sort of one of the main driving use cases here. So we wanted a dedicated storage solution that is sort of as decentralized as a blockchain is. And if you look at other decentralized storage solutions out there, like Filecoin or Arweave or some other solutions that are there, I think the key differentiator here is that Walrus is much more cost efficient. So, for example, we can store a single file with I think something like 4 to 5x replication. So if a file is just 1 GB, then we're at the end of the day storing 4 to 5 GB across 100 nodes. So the replication factor is quite low for something that is stored across like 100 nodes. And we operate in like a BFT model, which is what allows us like higher robustness than these other solutions. So even if like F nodes, like 30 nodes or something goes down, people can still retrieve their files. So that's in a nutshell, its robustness is what differentiates it from other decentralized storage solutions out there. And then Walrus uses SUI as its sort of governance layer. So for example, we call it blobs. So these are sort of files stored on Walrus. So every blob stored on Walrus kind of needs to go through SUI, in the sense that there is a blob registration event that is happening on SUI, which kind of says how much time this blob is going to be stored for, and then like Walrus nodes store the actual blob. And so this also lends a layer of programmability here, because like SUI smart contracts can suddenly see and maybe even auto renew blobs as and when they go, and Walrus nodes are just functioning by reading to like SUI events, and kind of that is how they know what blobs to store, who is the committee. All the governance aspects are kind of going through SUI here. So we're using SUI as the coordination layer to kind of build a net new storage layer.
Okay, so great. Another recent innovation for Mysten Labs, I assume famous research team as well, is Seal, which is a decentralized secrets management, or DSM service. Can you share more details on what exactly this is and why it is needed?
Yeah, sure. So Seal, as you said, is again out of the cryptography team. And Seal is designed to act as sort of a secret management layer. I'll probably, I think it's best to explain it through a few examples. Walrus, as I just mentioned, is only good at storing, like everything on Walrus is public. There's no encryption there. Like if you want to store, I don't know, personal backup, then maybe it's not a great idea to put your personal backup in plain text on Walrus. So Seal is more of a secret management layer. So it essentially allows you to store encrypted files where the key is secret shared between a set of nodes. So currently Seal operates in sort of a pick as you go model where each user who is kind of uploading a key can pick their committees. So it's not that we provide a fixed set of committee that encrypts all the files or all the things. And this is, for example, useful. Let's say if you are Netflix and you want to post, let's say, an encrypted video that you want to let's say share to people who have paid some fee for it on chain. So this allows you to kind of share your keys easily with others based on events happening on SUI. So it's not just a simple sort of a secret management layer, but it also allows you to share that secret with others. So that is kind of the key innovation here, which allows like people to build products where they not only store keys safely but also kind of give access to those keys based on arbitrary on-chain activities. So for example, you could imagine building a subscription service like this using this, where people get access to the key for a specified time, only a specified time. So if you kind of ask a seal, if you kind of ask a seal service to give you the key after that time ends, it won't give you that because that is what sort of the access policy says. And you can imagine like arbitrarily complex access policies here that you can just encode on chain, and that will tell and basically seal services are going to act according to whatever access control policy you've set.
So actually, Seal is complementary to Walrus.
Seal is complementary to Walrus, exactly right. So it allows you to it adds it adds privacy on top of Walrus, and on top of that, it also allows you to kind of share the keys, and so it allows you to make privacy itself slightly programmable. So you can play with who gets access to the key for how long, and in a sort of a completely programmable way.
Cool. I feel you guys are just creating many tools for folks to build applications.
It feels like AWS, but like reimagined, decentralized, but taking advantage of new opportunities.
Yeah, I think so. That's exactly this, right? So it's like you have a key, but now since we have all these cool tools, namely blockchains, we can make use of this to make access control itself like much more programmable than what is possible in a Web 2 world.
How does it work, Seal?
So the key challenge in Seal is that the set of users who you may want a particular file or a key to access can change based on on-chain events, right? So maybe it's a subscription and a new person has subscribed, so then you have to somehow give them access to it. So the way we do this is let's just say there is a single seal service off chain, right? So which is operating, so it's just a single key, and then the MPC version should be easy to understand. So what the seal service does is two things. So first of all, it continuously listens to SUI events, right? So that's how it knows who all is accessible to decrypt to get access to a particular key. And then the key itself is kind of derived in a deterministic way based on let's say a fixed key that that the seal service stores internally, and a particular identifier for that thing that you're accessing. So if it's a video that you're accessing, maybe that video has an ID, and it's a combination of the two. And this is where IBE comes in. We kind of the identity here is basically the thing you're accessing. So maybe if it's a video, that's the identity here, and we give you the key for just that identity, right, based on the on-chain activity. And now imagine this in a secret shared form where there's multiple seal services, and you have to do this with sort of everyone to get a share of the key.
Got it. Thanks. Um, I think that this brings us to the end of the show. To conclude, we have one last question, which we ask everyone, and it is to name a project you are bullish about.
I'm very excited to see the progress on ZKVMs in general that we've seen in the last few years, and hopefully we continue to see. I think, even just like 2 years ago, I don't think ZKVMs was even a thing. 2 or 3 years ago, and now it's like we have like running ZKVMs that can compile like Rust code, like C++ code, and like pretty much arbitrary code. So I'm very excited to see where that goes, and like how fast this thing can get. So that is just like a broad area that I'm very very bullish, or like very interested to follow along.
Absolutely. So, Deepak, thank you so much for joining us today. It was fun. I also think we learned a lot about SUI, about your work and your team work. For those interested to learn more, we've added some links in the show notes. So thank you again, and thank you, Queenie.
Thank you.
Thank you, guys.